So I hope everybody has prepared. You know, Albrecht was the one who really gave homework. So there were the YouTube videos which give like a start into the topic. Well, I have my hardware prototype here. It's very small and simple.
We want to see them immediately. I think we want to see them.
Well, it's pretty easy because it's like a side paper prototype to my. I have to put it on later, but I think it's a side prototype to my glasses. So I did a low fidelity prototype, but you didn't say anything of your expectations. Let's see how many students built something. Cool. So I think we are reaching already a good number of audience this morning. Welcome everyone to this third day of the Winterschool, and I'm so happy that we have yet another excellent keynote speaker for today. Even though I would say all of you or most of you probably will know Albrecht Schmidt, I would like to introduce you a little bit as an introduction. So he is a professor for human-centered ubiquitous media at the Computer Science Department at LMU, Ludwig-Maximilians University Munich. He created a course with his team on sketching with hardware. He created videos and tutorials, all the material that you need for envisioning and to create a new interactive physical object and really implement it with a functional prototype. And I'm sure he's going to emphasize this, himself. He's really making a plea for creating functional prototypes as part of the interaction design and implementation process. So today he's going to share some insights on how to create custom hardware using the ESP32 and Raspberry Pi Pico platform and Micropython. And I'm sure will inspire us also to really get our hands on to make the path from a paper prototype to a functional prototype. So again, Albrecht, very welcome this morning. We are looking forward to your talk. As I said, I have my paper prototype ready. Let's see when we will need it in your presentation.
So I think this would be Thank you so much for introducing me, and I'm really excited to be here and be part of the SPP. And I think we could, I'm not sure if people want to take a screenshot, but if you have your prototype with you, and you can put it on. We could take a screenshot of those who are willing to share their face with. Really take your prototype, put it on, because we take this prototype a bit as a starting point when we think of things, because it makes it much easier to think of things if you have an idea what you really want to do. Okay. So headphone, mask. I have yeah, I see most of you. I basically have cheated. I have my glasses on always, so I said it's just included. You can't see it, you know. It will pop up with the change of the frame. Basically, I changed the color of the frame, which obviously in a lo-fi prototype I cannot do. So this is my prototype, and I think we pick one or two prototypes. I think there are some which I envisioned. So there are people who created classes, and I think Marco created classes, I think. So perhaps can have a look at Marco. He has classes, and then Susanne did something similar to me, but much nicer. So she created wings on the side on her classes, perhaps the electroluminescent or e-paper, because we'll also talk about sustainability. Then we have, I think, more classes. Then we have additions to headphones. I think, yeah, we see Michael just turned the microphone on. Yannick has the addition to the headphone. And then we have custom-made devices. And I think I see Marian has one, like a headband style. And Rennie has also a headband with something additional on top. Anke has one with also a headband. And then we have the mask, which is very timely. Alia, I see there, putting it in the mask. And if you look out there, I think I've seen masks with displays, especially with smiling faces. So you don't have to smile, but the world thinks you smile. And I think you hopefully you did not spend much more than 5 minutes doing that. And we could now do a lot of iterations on this very quickly. And I will argue this is the right thing to do, but this is not the goal. Okay, so I start with this, and we have the topic sketching with hardware. What we do today is we look more from a conceptual perspective, a motivational perspective, and I give you the links to get started. And the hope would be that over the next year, perhaps, if you have really prototypes going in the SPP, we do a hacking session where we really get together and build stuff at some point. So I start with a quote. From the isolation of our workstation, we try to interact with our surrounding environment, but the two worlds have little in common. How can we escape from the computer screen and bring these worlds together? And I think this could have been a heading over the proposal Susanne wrote. I think this is sort of capturing it. And the interesting thing is, this is 93, and you may know Pierre Weller, perhaps not by name, but he did the famous desk. And I think, look for that paper. There is a really cool video from 1993. It's a WISP paper. He did basically projected augmented reality, a interactive work desk, and he built it largely. There's a lot of fake in the video. If you look at the WISP video from 93, there's a lot of faking in that video, but he built also some of it. And I think he learned a lot. And this challenge, once we go beyond the screen, it is really hard to stay with non-functional prototype and get insights. So there is more motivation to this. Probably many of you know Xerox PARC. Xerox PARC was a place that built things. They are known for building whole environments. So if you go back to the early time of Mark Weiser's lab, they built a smartboard. They built things like the pad. It is really an amazing set. If you can visit their showcase, they have still showcases there with a lot of the prototypes. Many of them are hardly functional, just functioning, but they allowed so much to explore. And you can go even further back. And that's one example I very often use in the lecture. So Douglas Engelbart he's known for building a mouse, but he's also one of the first people who built a video conference system. This is really an impressive demo from 1968. And if you look for Douglas Engelbart and the mother of all demos, you'll find that. And what he did, he used basically a tube monitor. He added more hardware in order to have multiple pointers. And so he could do video conferencing with a second pointer. And he knew at that time, this is not a technology that will be used for such systems. He was quite forward looking. He knew that digital systems will have this. But in order for people to experience a shared screen, a shared interaction, he built it with the technology he had at hand. And if you look at his demo, this is just mind blowing what he achieved with a technology that is obviously not sort of the technology that's going to use. And that's the first lesson to take away from the motivation. Don't say, I don't have the technology that's going to be used, I don't build it. Build it with something that creates the experience that people will have in your mind with the technology that is upcoming. A more recent example, which I really like, is the tangible interface, the reactable. And I think probably some of you have explored it at some of the conferences like TEI. And I think some of us were younger at that time and we all built a table. I'm not sure who of sort of the people who were older did have one of these multi-touch surfaces built in their lab, or know that the lab they were in had one. So I think there is quite a number of people, and I think it really created. It really created a stream of people building it, and it was because Kaltenbrunner and the others, they really put it out how to do it, and they were not the first one to do it. And there was Jeff Hahn who then built the company out of it, but it was really creating new experiences. And it was basically everybody had tabletops before, but this was the first time you could really see what happens if you can track 10 fingers. So again, this was something which really changed the game because people build it. And this brings me now to sort of the overview of the talk from today. And I start with, there is nothing wrong with paper prototyping, but. And I think we have seen in our field, and I see this really positive. When I started out, things like paper prototyping, qualitative research, research to inform design was seen pretty pretty harsh, and I think you had a hard time publishing this. And if you go back to old CHI proceedings, it was really hard to get things published in that space, which didn't have technology. And then we had sort of over the last year, people accepted and understood the value of sketching, the value of low fidelity prototyping. We teach it a lot. And I think it's really important. This is not something to be thrown out and say, oh, yeah, now we have to build it. This is really something we have to understand and to use. It is really the first step. But what I argue, it's only the first step. And what we have seen now in lots of publications, because it's so much easier, so much quicker, a lot of people stop after they have the Play-Doh system built and the paper prototype made and talk to some people and write it down. And they lose so much because they have gone so far. They lose so much by adding another week of creating something. They could really take projects much farther, insights much further. And that's my argument. Don't stop with lo-fi prototyping. That's why I made you lo-fi prototype something. But this is not the point to stop. So now also in the SPP projects, don't stop at the point when you have the low fidelity prototype. Go all the way. Create the user experience. And I think it's really important to understand what paper prototypes and low fidelity prototypes do and what they don't. So basically, if your paper prototype does not work, so if Susanne talks to 10 people and asks, basically gives them a basic introduction, what this does, and they don't get it, there is no reason to build it. There's absolutely no reason. If they don't get the paper prototype, then the idea, oh, once I make it functional, once I make it fancy, it will work. That's rarely going to happen. So if the paper prototype is not working, iterate. And I think that's the beauty. Iterate, make another one, make another low fidelity, till you have people who say, oh, I want something like this, I get this. And then you do the next step. Because if the paper prototype works, that doesn't guarantee you anything about the functional system. That doesn't guarantee that the system works. So we use paper prototyping, low fidelity prototyping, to prune our design space. And once we have pruned the design space, we can go ahead and build stuff. And I have put one very old example in there, and I think it's the start of the downfall of Siemens mobile devices, in my view. I'm not sure only the old ones will know that phone. I think it was really exciting to have this phone, but it didn't work. And you could already see it on the paper prototype, because if you make people type a telephone number on the paper prototype, they will be not able to do it. Because and at the time, people still type telephone numbers, because the telephone number you have to press on the sides. It's a really nice design. You can do this design where you don't have a touch screen and you can basically have the buttons on the side. And that works really very nicely for menus on the screen. But usually we have remembered things like our passcode or telephone numbers as a sequence on a keypad and not as the numbers. And so if you give this phone to somebody, you can see that they cannot type their passcode, nor can they type a telephone number. And at this point, having the paper prototype would have been enough to kill the project. But obviously, they built a product which didn't really work in the end. And take this as an example. That's why I put this old picture up here. Now, why do we do functional prototypes? What are the functions of these functional prototypes? So assuming we have an idea, we have really iterated our idea to a point where we really feel we know what we want to build. And we have a really good feedback from users that our paper prototype is something they want, something they can understand how it works. So we are there. And we may have also already published a first paper on this. That's completely fine. It's the argument, don't stop there. And this is one of sort of a Friday afternoon project I did sometime back in, I think, 98. And I think this showed to me the power of prototyping. And this is it is the most trivial prototype you can imagine. It's basically, it has two mercury switches. At this time, we still had mercury switches in the lab. Nowadays, you would have ball switches or accelerometer. And basically what we did is, if you turn and this was sort of an Apple iPhone predecessor, it's the Apple Newton, so my first Apple device I programmed on. We basically changed the screen orientation based on how you hold the device. And we basically had this idea that this would be nice, but at the same time, yeah, it was sort of something we just hacked it together. But what happens once we had it and we used it with people, and this is not something for everyday use. We basically, the first thing we saw, we thought it as a single person thing. But what we realized, if people interact together, they show it to the other person by holding it over and have the screen flipping to the other side. So we really learned a lot of things we did not think before. And this is sort of the most trivial prototype. And this is also one class of prototype we're going to talk about is you have a device, be it a mobile phone, be it a tablet, be it a projector, and you add very little external hardware and you get a new functionality. And I think obviously you could tell people in an interview session, oh, look, imagine I switch the screen once you turn it. You could do even this with Wizard of Oz, where somebody sits there and tries to switch, but you will not get the fluency of sort of interacting with the device. And so it is really this point, it creates new ideas. And what we also have seen, we had ideas, and once we build it, basically even before the first one was ready, you come up with what do you want to have in the next one. So it is really a way of thinking about your designs from an engineering perspective. And I have one project in there, and I think I've seen Christoph van Laarhoven. Christoph, I have to send you old pictures while digging that out. I found pictures of times when you were young. So this is something Christoph van Laarhoven and myself had the same or have the same PhD supervisor, and we were together in Lancaster. And I have here one example of something we built. So basically what you see is a table that has load cells built in, like scales, and you can see what people do, whether they put something down on a table, like whether they put a cup down, they put a book down, whether they sort of move the hand over the table. So and basically we started out building this as a uh, object recognition table, object and position recognition table. But the second iteration we built was a pointing device on the table. Because once we had it, we realized we can easily basically simulate a mouse with it. Because when you move objects around on a table, you can use it as a pointing device. Was not really thought of, but it just the idea came once you had a prototype, and we had this time at that time a living lab that was not always running, but it was running quite a lot of time. What is another thing you can do with functional prototypes? You can do quantitative comparisons, and this is sort of an example where we looked into technologies for firefighters. This was Yomna Abdelrahman did this, and she built a device which you can have on the helmet and one which is handheld. And we looked basically what does it do for people. So you can use it in somehow realistic context. In this case, you could not go with them into a burning chamber, but at least you could go in a smoke chamber. I think you could do things that are not hot. But it's really this point where you get people in this stressful situation trying something out. And for this, you have to have a device that works. And I think now the big question is why is not everybody doing this all the time if it's so great, as I say? And I think why not to do it, I also pulled one example. It requires sometimes a lot of effort. So I think I have here one system Markus Funk built. I think he spent 1 year of his PhD more or less solid implementing a system because we had it was a project together with a workplace for people with disabilities and also with Audi. And if you want to try your system in a production environment where people work, it better works. They don't let you in with something which is held together with duct tape and we have 5 people and say, oh, we switched then to the next step. It is really this point. Sometimes if you, but at the same time, what he managed, I think he has still one of the biggest studies with people with disability in the ACM Digital Library because he built a system and he got in. And I think at the beginning, I think we had a lot of discussions. It was extremely frustrating. People do a questionnaire on Mechanical Turk that sort of 3 days of work, they write up the paper, get another publication. And I think he was still sort of in the lab with a number of student helpers create a system. In the end, it paid off for him. He really created sort of a body of work that's seen. So I think this is also this delayed gratification is the problem. And I think we have started in our community very often to go for the low-hanging fruits. And so I think with the SPP, I think we have really the chance of not having to publish in 1 year. Nobody will basically, if there is the Chi paper not out next year, this is not harming your project. I think if you don't have anything after 4 years, that's really tricky, or after 3, but I think it's not so that you have to push out. So you can go for the delayed gratification. And for this, I think I've put up a number of prototypes we did here in the project Amplify that all show different things. And I think if you look at the head here, this looks really funny. This is a device for selective hearing. We had a hard time publishing it, but I think this is sort of, it is not a guarantee to get great publications. On the other hand, this one got an honorable mention at Chi, so this is a swimming goggles. And they also, all of them have their tricky things once you build them. So building something that's watertight is tricky, I tell you. But again, we are getting better in the lab. We have better 3D printers. We have better materials. Building something you use in road traffic, again, sort of the stakes are getting higher. The ethics committee will ask very close how well this works, and you have to provide some guarantee that you don't hurt people. So I think my experience, and that's sort of the summary of this first motivational blog, is it's really worthwhile, but it has these things of the delayed gratification. Okay, so now comes sort of the real tricky point, this trade-off between the development effort and the insights gained. And we obviously have seen in the community, and I have seen it in my own group, swinging in both directions. I had people who basically, there are few, but who basically got so far into the development effort and so excited about building devices that in the end they didn't really do a PhD. So there is a risk when you build systems that this gets really exciting and you forget on the way that you do this in order to gain insight. You become sort of an engineer, and this is sort of not necessarily a bad thing. If companies come out, that's an outcome which I find quite okay. So basically, if you get really good at what you build, sort of the PhD may be not an interesting thing after some time anymore. It may be sort of getting the product into the market, getting sort of as many users as you can imagine. And so it is really the question, what do you sort of take from your paper prototype? And this is sort of coming back now to your paper prototypes. What does it take to allow people to experience your idea? And I think, I'm not sure how much you read into the paper, and you met Jonna yesterday. It is really something, it's an experience for the wearer as well as for the environment. So probably you come to a point, it has to probably work for a few days. Otherwise, you probably don't get this experience you want. And so you really have to think, what is sort of the minimum you have? Where do you do Wizard of Oz? So for example, let's say I take Susanne's, she's on the front of my screen, these wings. Let's assume we have something where we use, let's say we use a bit of plastic, where we stick an LED on, and we can change the color of the LED. And I could imagine I can create a prototype of this very quickly, where I can remotely change the color. I'm perhaps not bothering with the sensing, and this is the question. So I do basically Wizard of Oz. I say, I make Susanne look to certain people stressed, and to other people I make her. So I take Susanne as part of my experiment. She is not the subject. She is really part of the experiment, and I just see how people react to her. So I even could do it not wirelessly. I fixedly program it to red and let her walk into somebody's office. And basically, there was perhaps a team meeting where people have been communicated what this is, and I measure the reaction. So the functional prototype could be really on this very simple side, but it could go all the way over to I have all the system implemented. And this is sort of the thing you have to sit down, and this is typically that goes together with writing the paper. So the idea here is, if I write a paper, what do I want to report? What do I expect as outcome? And with this, I think, what do I have to build in order to prove or disprove that this works. And if I want to make now this next step with this paper and say, I want to argue that people really change their behavior towards Susanne if she goes in, if she has it, I don't have to implement the sensing. I don't have to implement some fancy transitions while she walks from one office to the other. I can do this with basically a fixed color. I could even perhaps build 5 of those classes with different colors and just clip different things on there. It could be really simple, but I would get sort of this reaction. On the other hand, if I want to understand how it links to the sensing, how the person who wears it perceives it themselves, if the sensing reflects what they do, I may create another prototype. And for me, this is something when looking at this, this is really, you have to have the paper in mind. What do you want to, basically, what insight do you want to offer the community? What insight do you want to prove? And what does it take from your paper prototype to get this additional insight? The simple case is, if your paper prototype gives you that insight, don't build anything. There is no reason to build it. But if the paper prototype doesn't give it to you, then obviously you want to build it. And I think there is sort of this, if you build it because you're stuck, you don't have new ideas, you have paper prototypes, you don't get on, build one, and that may lead to ideas, what you can change, what the issues are. You can iterate over physical design. This is much more costly than iterating over a paper prototype, but we'll look later that with certain platforms, and very often the iterations are then more on the style of iterating the appearance than the functionality if you program it right. And I think the key thing, what we very often want to do is really run studies, do quantitative comparisons, and this puts the stakes up high for development. And there is always the risk that you basically get then sort of drawn into product development, which is something completely different. And typically as HCI people, we are not really good at it. We have sometimes in our lab, we have people with electronics background, but if you don't have an electronics background, the idea of building a mobile phone from scratch, what I've seen sort of in a lot of examples, is usually not working well. And you will not convince people that this makes sense. So how to enable an interactive experience? And that's really sort of the whole set of things. And I've put this arrow in here. It gets harder if you go there. Basically, building something you can try out yourself. This is very often very easy because you know what you want and you can abstract from all the cables that are hanging off. We have one thing, I think we had more discussion recently about self-experimentation, autoethnographic studies. This has a bad it has a bad connotation in our community, but there is some value to it. It is just the way you have to report it. It's basically this user study of size 1 with the developer as the user. And obviously, this can go seriously wrong depending on what you do. But at the same time, this again could be a first step into creating something. So I think, first person research is great. I know Mark is liking that. And I think we are the generation, we like it. And I think it's not because I think perhaps it's a bit, well, we are lazy at sometimes, but I think this idea of what you can learn, and I've recently reviewed PhD dissertation where there was one chapter on self-experimentations. And this is really interesting because it's like eat your dog food. Because if you basically have a software that you have to use every day, and it sucks, you don't give it out to users. And I think a lot of the idea, people build something and say, oh, it's not really working well for me, but I try it with others. That's again sort of, it's this pruning of the tree. If you don't, basically, if you're happy to give it up after you tried it for a week, I think other people are giving it up. And I think, again, sort of, if you look around in the community, and I have examples, I don't know names, you go to a lab, they run a study with this awesome, and I have one example of it's very old, so I can tell it, of basically an intelligent environment that links two rooms. And they were really excited. I got sort of half an hour introduction about the study, that everybody likes it, that they would never go back to something with this. I then see the Kai paper. I'm really excited. I come back 1 year later to this lab. and there's basically the old screen hanging at a kitchen window or next to the kitchen window, and in the other hallway the screen is already taken down. And I ask, oh, what happened to this? Oh yeah, the experiment was completed. It was really just too much effort to keep the two devices running. And it was basically a camera screen link. And this is sort of one of those things where I feel we have sometimes this issue. If we would use self-experimentation, we would not end up with things where we sort of hype ourselves up and get it running, get it published. And so basically, don't fool yourself with the self-experimentation. It's only something to prune out technology that's not working. Then the next step is demonstrating something in front of a focus group is really easy. That's not hard. You don't need much because you can fake a lot. You can do a lot of Wizard of Oz. Showing it at a fair or a demo session, again, we have seen a lot of fakes. And I think once you, yeah. So if you can be a student volunteer at one of the big demo sessions, and I think Jan has organized, I think, his fair share of demos at Kai and Wist. So I think once you see the broad range of demos people bring, you see also there's a lot of fake in a lot of demos. But this is not bad. It's really communicating the idea. It's not meant. This is not something that's wrong if you fake parts. It's really you want to create the experience. But I think then we have sort of at the long thing is basically what we talk at the moment. You build a device, you put it in a poster envelope, and you send it to your users, and you call them up 6 weeks later. How does it go? This is really sort of the thing. You have to be really good because that's sort of people expect more or less product style technology, robustness, and support. So I think this is sort of a bit, and you have to make decisions. And the typical thing is you go through those steps, not necessarily all of them, but I think don't leave the self-experimentation out, even if it may not give you a paper. This may be sort of delayed gratification, but the insights you get are really strong. And this brings you to the point, what do you want to include, what to leave out? Because obviously when you build a new device, you will leave stuff out, which will be in a later product, but you leave it out. There's one question that says, is this not also close to the term probe, where we need to work for long in the user environment? I think if we go back, I think probes can be on all levels, more or less. They can be on a demonstrating. So we did some years back with Lucia Terengi, we did something like displays in the home where we had functional stuff where we went to people's homes and we showed them like in a context like with a focus group style. This was a probe, but there is also the probe where you send something to somebody and you record how they use it. So again, this is sort of, I would see the probe orthogonal to what we see here. So what functionality? And I think one of the great challenges is to get it in the size and weight you want to experience it, especially if it's mobile devices. Now, if we talk about the headset, if you create a headset that is 3 kilograms, you cannot expect people to wear it all day. If people wear already a headphone, you could do something like, oh, I go for the headphone, but I give people something like a mini rucksack to wear. Again, this may sort of change the experience, but this may be an option that you divide the device up. You say, and for example, when we did the goggles for swimming, we had at the back of the head a little box with the electronics. Obviously, we imagined that this would be in the classes somewhere, but we could not build it in the site. So we went swimming and we looked, where can you put something that it really doesn't change the experience of the person? And I think for the headphone, you could imagine that you have sort of a cable for the classes, or you have something where you say, I'm only doing the display stuff on the classes. I separate my questions out. I think display fidelity is something, usually the bigger your display, the better your display, the more processing power, the more battery and so on. And this is sort of tricky. How polished you have it. And there is one link to an interesting paper that comes from the paper prototyping side. If you have it too polished, people will give you a very different feedback than if you print it with the 3D printer in a coarse print. So let's say you have the same device and you print it with the ugly plastic with the riffly surface. versus you get it printed in shiny metal from a third party. You have the same device, you will get completely different reactions from users, because in one case they feel, oh, it's just a prototype, I can speak my mind. In the other one, they think, oh, they're really close to a product, so I give very small comments. And there's also literature about this, that by the way you design the appearance, you elicit reactions. And now this is sort of something, if you want to build something, what would you use? And I think you had to look a little bit into the thing. So imagine we have something roughly the size of a cigarette box. It should run for 8 hours. It has a small screen. We only need sort of a few lines, but it should be high resolutions. It can be remotely controlled. It has a light sensor, it has a temperature, and it can be audio feedback. How would you build this? How long will it take to build this? It's a real question. I just check if everybody is still sort of awake.
Well, I guess it also depends again on what we decide for how to create it. If you do repackaging, or if you start all from scratch.
In this case, what would you choose? I think you had the right keywords. What would you choose?
I probably would repackage things.
And I think this is the right decision. I think you probably would repackage either a mobile phone because you need a remote control, or an MP3 player which you can program. I think, and this is sort of the first, that's the really important thing, to understand that you cannot build an iPhone. And again, sort of I can show you papers, and they usually get not accepted, where people basically build a mobile phone. And they try to get the form factor, the battery runtime, and so on, and they don't succeed. It is not trivial to build a mobile phone. So don't do it. But I think if I change now this one to, so this is the take a phone and repackage it. So I think if I add an air quality sensor, the question becomes more tricky. How do I do that? And in this case, we would probably repackage and add technology. So I would probably try to build something where I connect an air quality sensor to something that has Bluetooth, and I put them together in a box with a phone. And now comes the other question. Yes, I want to put this into here, into a pump. Good luck with repackaging the mobile phone. And I think this is the point when I think for the user experience, for my experiment, I need to get it in there. And the air pump was just basically the first picture I found yesterday night. So take anything that has a shape or size where your phone doesn't fit in. Then you have to rethink it. But at the same time, if you find a phone that has the form factor, and if you go to AliExpress, the number of Android phones that are small and that you can put in. So this is sort of one area. If you can do it with a phone, don't bother with anything else. This is sort of also a take-away message for mobile devices. And I think also if you can do it with a big screen on the wall, don't bother with doing something else. Okay, let's move on. So ways of building functional prototypes. And there is one thing which we sort of discuss quite often is, do you go the evolutionary way or do you go the revolutionary way? And I have the example of the cars because that's a very obvious one. Do you consider your device a device with computing, or do you consider it a computer with additional input-output? And I give you an example, which is, I think, if we would be in a real Winterschool, we probably would have now half-hour session where I give you all a hair dryer, and I tell you how would you create an intelligent hair dryer. And then I would ask you to go both ways. The one way is to consider the hair dryer and see where you can add sensing, processing, actuation into the hair dryer. And then I would consider you think what are the I/O components of a hair dryer, and you would figure out this is something that blows air and this is something that heats air. And then I would ask you, take a computer and add those two components to it. What new hair dryer do you get? And I think here, for the evolution, you get sort of fairly mundane prototypes from these groups. This is a hair dryer that perhaps measures how shiny your hair is and adjusts the temperature. So And I think if you go the revolutionary side, sort of the typical thing that comes out is a drone that dries your hair while you walk around your house. And this is sort of, again, sort of it's quite reliable that people will come up with this. And it's just because you think from a different perspective. And I think my argument is if you build something which has sort of related objects, and I think looking through the project in the SPP, we have a lot of things where we move from products that are out there, go both ways. Do deliberately a session where you say, what happens if I put sensing, actuation, and processing in what I want to basically improve? And the other way, basically think what IO technologies are in that, if at all, or with what IO technologies can I change that and think from the computer side. And now I have sort of a quick walkthrough, and I think you've seen this. If you have seen the other video, you have seen this. So there are basically three things we typically look, and one, there are two. Sorry. So repackaging is very powerful. And I think if you look into a lot of work at Kayet with repackaging, and I think it is not like a lot of people say, oh, that's like cheating. No, it's not. It's really, it creates something completely different. So we had this in a European project. This is an iPhone doing augmented reality inside a device that looks like a loop. And it completely changes how people interact with it. It's a nice woodenly designed loop. You go over objects, and it's completely different than having your phone. And I think it has two aspects. One is sort of our expectation of the device can be changed, but also the phone is in our mind a multi-purpose device. There could be any time a WhatsApp coming up killing the experience. So if you go on the user's device, you're not monopolizing the usage, or it's really hard to do that. So repackaging could also be repackaging, just giving them another phone that's a bit repackaged in order to contextualize it, but also to monopolize usage for the technology you have. Then the second part, and I have a picture of Enrico. I'm not sure if he or a student of him is here, which I really like. This is sort of a system, and again, the vision is here, that you have something on your belt. And this is a bit in the tradition what I said of Douglas Engelbart. I think Enrico and the team, they knew people are not wearing a rucksack with a projector. But in order to experience how this is, and Christian is here shown with it, wearing it in the pedestrian zone in Ulm, and they're a really nice story, so you should talk to them at some point. If you walk with a projector backpack through Ulm, that's an interesting experience. But I think what he could really see, he could see how it feels. And I think what you see here, he did first the experiment himself. He didn't basically send the users out. He went there himself. Obviously, later they sent users out, but he went out and tried it himself. And it was really the idea, how can I create this experience by the technology I have, well knowingly that it will take another 10 to 15 years till you can build something like this. And very often this is either you basically plug together standard components, this is very much here, but very often you have add-on hardware as a glue, where you basically glue some additional sensing, or you need sort of format conversions on a hardware side, which is basically building some custom hardware. And the last part, this is what we did also, and what Susanne referred to, I'll show you later the website, is basically how to build your custom hardware. And this is sort of for us, we do this in things where if there is not a device, if I can't get the form factor, if I cannot build it from other devices, then I go there. Don't go the other way around. And I think we have a lot of people who are very excited about a custom hardware, but this makes only sense if you cannot get it by repackaging, and if you cannot build it out of systems that are out there. Then you build custom hardware, but you have to have a good argument why you do it. And now what can you build? And here I go quickly over it because we have a lot of the information in the wiki. And as I said, there is hope that we do sort of a real hacking session at some point where I would be really excited to do. So basically, we have now a lot of processing boards, and in the wiki there are some videos. There is a new Raspberry Pi Pico. This is a very easy start, and we are at the moment work on a sort of like a workbook hardware prototyping or hardware sketching with hardware using Micropython. So if you program Python, I tell that you probably within half a day you can build a lot of things. And I think that the easiest platform, and I think that was one of the links I gave you, is to start with the Raspberry Pi Pico. If you can get your hands on it, we got some they will be shipping sort of in large quantity from next month on. But there's also the really cheap ones. They're at 2 to 3 euros. So you could imagine to build 100 for, this is an ESP8266, and this is the ESP32, which has a display. It's about 15 euros. So it's really cheap, the hardware, but it's the cost is not the hardware. It's usually basically getting it done, getting it packaged, getting it to the user. So there's a lot of cores, and the first thing is choose the right core based on whether you need sensing, networking, etc., or what size you have, and they get really, really small. And I think there's one other thing. I think the only person who usually does their own course is Christoph. I think he's also here in the. So if you do your own core, talk to Christoph. He will tell you that this is probably a tough idea to do your own core. So I would at this moment not do my own core because there's so many cores out there. So just go for a core you can buy. Then sensing, there is a lot of sensing out there. We have, yes, do your own core. So Christoph is in the chat, so yes. I think we can discuss this a bit further. So basically, there's a lot of sensors out there. There are a lot of lists of sensors, but there are two things to remember with sensor. And this is also something going back to early days. I think Christoph may remember this as well. If you want to build a wearable device that detects whether you are speaking or somebody else is speaking, this is a really tough problem if you have a single microphone. Every idiot can program it if you have two microphones. Basically, if you have one microphone towards the speaker, in this case, a throat microphone, and one to the environment, it's really easy to know whether you speak or the other speak. If you try this with one microphone, you have a lot of processing. Another one is you have a cube and you want to check the handling. If you put a single sensor in the middle, this is really tricky for some of the, if you put 3 sensors on the faces, it's much easier. So if you think of sensing, think of sensor placement. Where do you put the sensor? And take this microphone example. If you put it in the environment, it is, if you have multiple microphones, a lot of ideas are easy to realize. If you have a single one, you go hardcore AI. And I think the thing is, if you prototype, if you can solve it with more hardware, don't bother with more programming. Obviously, in the real world, once you make products, you want to reduce the hardware. So the design options in prototyping is really, if we can solve it with more hardware, just throw the hardware at it. And one final point on sensing is that basically a light sensor not only gives you light, it can give you basically whether you are in the US or in Europe on the frequency of the light. It can give you whether you're indoors or outdoors. You can even build a touch sensor with a light sensor. Because if you hold, basically usually people are operating in a lit environment, and if you put your finger over it, it's dark. So I think this idea, basically what sensor do I need, is much more complex. So what can you get out of a sensor? And you can basically look at different sensors. You can use, for example, a temperature sensor to get speed. There's quite interesting stuff. Obviously, you don't get precise measurements of speed, but you can see whether a device is moved or not. Actuation, again, a lot of stuff we have in the hardware list, and we can have a quick look in here that you get an idea how this looks like. I see we have to find the screen. So we have a hardware list here. And for example, now let's just jump into one of the actuators. So there is these NeoPixel rings. Basically, this is sort of, you can get also them as strips. There are multiple LEDs. And so if you go into the wiki, there is something how they look like. There is typically a drawing how to connect them. And then there is a piece of code how to run them. And there is some more code if you do sort of something nice with it. And then there is a video how to connect it. This is sort of for most of the components we have this. And as I said, we at the moment work on sort of a booklet that makes sort of different paths through the wiki. So, and networking is another one. This is in the components. Typically, do you want to have Wi-Fi? Do you want to have Bluetooth? Do you want to have wires? And here, basically, my suggestion is if you can do with wires, don't bother with much else. Wi-Fi is also really nice. Bluetooth is still sort of more tricky. And again, here I show you something. We have here a networking tutorial in there. So we have done this with students, and I think it's really easy to basically, what we did is we built a Blackboard architecture. That's the question. So you can write variables to the internet and you can get the variables back. It's a bit like Dropbox for single variables without any safety. But I think for prototyping, again, this is something that works quite well. And this one is also on power supplies. This depends. If you want to have a 1 hour run in the lab for a session, that's really easy. If you have something where you give it to people at home, you have to really think what to do. And I think if you want to go into power, Christoph van Laarhoven is also one of the people to really talk to about energy harvesting, etc. And I've even put a picture from Christoph in here. Basically, there are ideas how to do this. So you use a sensor that uses very little energy and you use this to boot up your device. And so, for example, if you have something which is switched off, it usually needs very little energy. This is the sleep mode. And so, for example, if you want to build a device that reacts when you pick it up, you have 200 milliseconds before you switch it on, because if somebody picks it up, they will not realize for 200 milliseconds that it doesn't work. So you have time. So you could basically let it sleep 150 milliseconds, test for 10 milliseconds whether it's moved, and then go to sleep. So you will massively reduce the energy. And this usually gets us to a point that we can run 1, 2, or 3 week experiments with simple batteries. So, and I think, again, don't overdo this, otherwise you may up in a company. I think we had sort of this with other sensors, and people have them now down to 5 years runtime. But this is sort of more, again, a product and not something you want to publish it at WIST or UBCOM. Now, about taking shortcuts, and I see we're nearly at the end. It's another thing what we sometimes do, and this is an example of a web clip where you can basically use any mobile phone to connect external hardware, and basically you simulate touch on the screen. I think it was published 2014 by some of the people in Stuttgart, in the Stuttgart lab. And basically what we built one which basically has the form factor, how it should look like, and one that worked. And for the study, we let people do it with this, all the way to the point where they had to connect something there. We used this one. Again, sort of try to sort of see, this is like a paper prototype or a high fidelity paper prototype, non-functional, but we could do calling the app and all these things. And here, that was basically then the thing to try things out, how it works. And I think, guys, come to the end with Bob the Builder. And I think there is reuse, reduce, recycle. If you haven't seen that episode of Bob the Builder, you should probably look at it. And I think one of the things is, in the long term, we don't want to have more devices that are useless. I think this is sort of something, if you don't need the device, don't build it, don't even prototype it. If there is no good reason why we want to have this, don't do it. Because I think we have enough stuff out there, and we don't want to pollute the world more than necessary. You have to have a good reason for a device. And obviously there are often good reasons for devices, but make sure and also add this to your paper, why you think we need yet another device. Why can we not do it without a device? And I think that goes all the way to, if you now think of your projects, if the things you're doing work better without computing, switch. I think it's still the time. I think really, is there something where you need a device, then build it. And I think from prototyping, build it. But if there is not a good reason, reduce, don't do it. And I think for prototyping, what we usually do is, and this is really hard, you build the thing, you run the user study, and you really like it. And I have sort of a cupboard full of prototypes. And they have some historical value, but I think usually one is enough to keep. Reuse the others, and don't wait with reuse another 3 years, because then you cannot really reuse it, because then the platform is out. So my suggestion is, if you have built something nice, if you have built something for a study, keep one for reference, but reuse all the other components you can. And I think with this, we would be at a breakout group, perhaps make this as a homework. I think one final thought is, there is one side effect that's really nice when you build stuff. It increases your market value. So if you, and I think this is generally, if you do hard stuff, which not everybody can do, where it takes learning, where it takes sort of effort, and this could be on a methodological side, this could be on a technical side, this could be on AI, this could be on hardware. Once you are able to create functional prototypes, you have a skill a lot of other people don't. So I think it's an investment also in your training to do that. And I think obviously that's a decision whether you're interested in that. And I think looking back at my career, I think we were very early to have a hardware lab. And so basically my early career was sort of on a vocational training. I got some electronics training, and this enabled me to do some of the stuff. But at that time, I think we would have not had a lot of publications if we wouldn't have built hardware. And perhaps I would have gone in another direction, but I think it's something you obviously train yourself in something. So this may be an interesting investment. There are some references, I already gave some, but I think it is not really complex what we talked about. It is really sort of about making clever choices, and once you know what you want to build, create things. And I think for this, I go with this last slide. So I think one of the tasks would be now in groups to define how you would take your prototype forward, how you would create your prototype. But this is something, and it was not seen realistic, but this is something where you would need to go through the wiki. And this would be something like a 1-hour session where you come up with a real design, what you would need to program, and then estimate how this would take, how long this would take. And I would guess for many of the prototypes you had on your head, we would have, if we start today, by the end of the day, a show of devices that could be used for studies, and you would have gone through a training phase. And I think this is the final remark. By going through, basically, if you want to learn about sketching with hardware, don't learn about sketching by hardware with hardware. Take a project you want to build and do it. Otherwise, it's all simple. So if you take this one, you will run in a lot of problems, but by solving them, you learn. I think the idea of just following the course we do with students is we just do this for the very first few hours, and then they have to pick their project, and this is fairly open and they have to specify what they want to do. And then once they do it, they really sort of struggle with things, and that's where learning happens. And I think with this I stop, and Mark has a comment. I haven't expected less. Thank you.
First of all, thank you very much, Albrecht. That was very insightful, and also I think a big variety from us bringing paper prototypes to you making a plea for functional prototypes. Thanks for bringing this all to this Winterschool.